Okay, hello everyone. This is Heiyang from Midas IT. I would like to start the introduction of Midas Gen today. If you have any problem in this sound, please let me know via questions window. Or if you can hear me clearly, also please inform me so that we can start the introduction. Thank you very much for coming today. So can everyone hear me clearly? If you inform me via questions window or chat window, then we are going to start. Hello everyone. If you can hear me, please let us know via questions window so that we can start the Midas Gen introduction. Thank you very much for coming today. Web Business Integrated Solutions. We are exporting Midas family programs to more than 60 countries worldwide through headquarters and distributors in 20 countries. This shows the Midas family programs. Among those, as you can see here, Midas Gen is for the building structure as well as general purpose structures like plants or stadium, so on. So let's see the product overview. This shows the strong point of Midas Gen. Firstly, we provide the seismic specific functionality. So we can enter the static seismic node response spectrum analysis and linear nonlinear time history. And also we can assign the base isolator and dampers. Pushover analysis is another strength in Gen. And we provide the comprehensive design code, as you can see in this list, for the RC structure, steel, SRC, footing, and slab walls. And we can perform the highlights building analysis as well for the column shortening results in construction stage analysis. So we can fully consider the time-dependent material such as modulus, creep, and shrinkage during the construction stages. And even though we are considering the high-end analysis features, but most important thing in Midas Gen is easy to use. We provide the intuitive user interface such as worktree and easy model creation and modification, and some other useful features we will see during the demonstration. So let's see the graphic user interface first. This shows the framework of Midas Gen. This is the worktree. So using this worktree, we can check all the entered data, and also for assigning the boundary condition or loads, simply drag and drop from the worktree, we can simply assign them. So it reduces our modeling time, and also it reduces our modeling mistake as well. And for the high-end analysis features such as pushover analysis or material nonlinear analysis, we can use the task pane. It will show us the required steps, and then after performing analysis, related post-processing will be displayed in this list. And some other various useful functions like multiple viewpoint and tables, different display modes, and table windows, and various type of graphs. And also, One of the strengths of Midas Gen is visualization. So as you can see, we can use the transparency to check the columns and gutters inside. And also we provide the walkthrough effect to check the model with the various viewpoints in the pre-processing as well as post-processing. And file manipulation is very important these days since various engineers work with the various software. Midas can fully handle the file manipulations. As you can see, we provide the direct data transfer with Tekla structure and Levy structure. Also, we can import the data from STAT or SAP Nastran, and also direct data import and export from AutoCAD DXF file is also available. And in the complex project, when the number of engineers work together, we can merge those separate model file into one analysis file using our merge data file function. And all the data can be entered in the text format as well. So for the duplicated, the similar type of the data, using this MGT command shell, we can easily enter those data. And some other useful modeling features such as select identity, active identity, and user coordinate system are provided. And also we provide the unlimited redo and undo function. And also graphic editor and print functions are available. Let's see the model data generations. Midas provides the various material database, and also we can specify the user-defined material as well. So most of the international database has been implemented, such as British Standard, American, European, Dutch, so on. And also we are continuously updating those databases. And also we provide the database for the time-dependent material, for the clip shrinkage and compressible strength based on the Eurocode, ACI, CBFIP, PCA, so on. For the section database, it's same. We implemented most of the international database and also it is continuously updated. We can also consider the tapered sections and also steel concrete composite section is available. For the typical shape, we can enter those shape of the sections. And when we need to enter the arbitrary shape of the section, we can use one of our useful tools which is called Section Property Calculator. Using this SPC, we can directly import the AutoCAD DXF file, or we can directly enter the shape of the cross-section. Then SPC will perform the finite element analysis to provide the required section properties. Then this can be imported in Gen. And for the typical shape of the structure, we can use the wizard. We provide the beam wizard, column, arch, frame, truss, plate, and shell wizard. For model buildings, there is two ways to create the buildings. One is modeling slabs with the plate element. The other way is model slabs using this floor diaphragm. Both ways are available in Midas Gen. If we consider the floor diaphragm, the program can automatically assign it using the story data. This story data also can be automatically recognized based on the z-axis nodes in the model. And mesh generation is also available for the AutoMesh and 4-node map mesh feature. So we can create the plate elements using our AutoMesh feature and then perform analysis, and we can check the analysis results like displacement, reactions, and member force. And then we also provide the slab design features as well. This shows the various applications of our AutoMesh feature. We will see the automation feature during the demonstration. And let's move to the load and boundary conditions. Midas enables us to specify all type of nodes, elements, point surface, or dynamic pre-stressing load, as you can see in this table. For the floor loads, we can consider both 1A floor load or 2A floor load, 1A slab and 2A slab. Once we specifying the area, the floor load will be automatically distributed to the connected beams and columns. Also, we can consider the sub-beams as well as the self-weight of the sub-beam. For the plate element, also we can use the pressure loads function as well. Seismic wind and static seismic and seismic loads are available. So by specifying the corresponding loads, as you can see in this table, then we can enter the data automatically. If the flow diaphragm is assigned, then the wind load will be entered to the diaphragm center, dimension center and also static seismic load will be entered to the mass center of the each story. And if we model slabs using the plate element, also we can consider those static wind and seismic load as well. And for the dynamic load, we can enter the response spectrum load or time history load. For the time history load, we provide the earthquake records and also hill drop database. I'll briefly show you the flow vibration analysis using the program. This is the one part of the building to evaluate the floor vibration. Here, we assigned the floor load using the dynamic nodal load. So load has been entered using dynamic nodal load function. And as I just mentioned, we provide the database for the hill drop, working load. So following working loads can be assigned, or we can directly enter our own function in this table. From the Microsoft Excel, simply copy the database is available. Then after performing analysis, we can evaluate the results. Let's check with the animations. So all the results can be checked with the animations, and in this time history displacement, we can check the flow vibration with the time function displayed in this window. So these results can be checked with the time function. We can check the time function here. And also we can check the various graphs for the time history results. For example, let's check the accelerations with the time domain. So this hysteretic curve can be checked, and also we can change the graph to the frequency domain. And all the results can be saved as an image, text, or Excel format. And also, in order to consider the lateral earth pressure, we can enter the hydrostatic pressure load as well. For assigning the mass data, we provide the various type of the mass, such as nodal mass, flow diaphragm mass, load to mass, consistent mass, and self-weight to mass. And in order to create the most realistic analysis model, it's necessary to give the proper boundary condition in the model. So Midas provides the various type of the boundary conditions, as we can see in this table. Here we can see that some part of the slab has been entered with the rigid link, and the other part has been entered with the plate element. Here we can assign the isolator at the bottom of the column and the flow diaphragm we mentioned previous slide. And this shows the behavior for the fixed support and with the isolator. And pile spring support can be considered for the soil interaction. For this, we provide a point spring support with the various type. Multilinear type can be considered. And also pile spring support to model the piles for the piles in the building. And also surface spring support can be considered as well. And Midas can handle from the simple static analysis to the high-end analysis like geometry nonlinear or material nonlinear analysis and construction stage analysis, pushover analysis, so on. For the construction stage analysis, as I mentioned, we can fully consider the time-dependent material during the analysis, and then we can check those 3D column shortening results. And flow vibration analysis, we just checked with the model file. And pushover analysis. For the pushover analysis, we provide the hinge type for FEMA, Eurocode, multilinear, and also masonry user-defined hinges. Once we perform the pushover analysis, we can check the pushover curve, capacity curve, and we can evaluate the structure corresponding to the specified response spectrum function as per the FEMA and Eurocode N2 method. And we can check the hinge status for each different steps as well. This shows the masonry pushover analysis results. And this is the hinge status for the 2D RC frame building. And we can also consider the inelastic time history analysis, as well as the boundary nonlinear time history analysis. And here we assigned the isolator at the bottom of the columns. With the time function, we can check the behavior of the structure. And also we can consider the fiber analysis. So instead of model those elements with the solid or plate element, using the beam element by assigning this section, we can perform the fiber analysis, and then we can check the cracks and stress of the cross section. For this, we provide the database for stress strain curve. And heat overhydration analysis is also available. This shows the solid stress with cooling pipe and without cooling pipe. And some other nonlinear analysis like material nonlinear, plastic analysis, and also geometric nonlinear analysis and masonry analysis using the solid element. This shows the material nonlinear analysis. And geometric nonlinear analysis. Structural masonry analysis. We can check the yield points with these X dots. And some other applications using our masonry material. Midas provides the most of the finite element type, as we can see in this table. Especially Midas provides the wall element. Using this wall element, we can model the shear walls in the high-rise building. So comparing to the plate element, we do not need to make the mesh, so it will reduce our modeling time as well as the analysis time. And also for the brace, we can use the tension-only element. And let's go to the post-processing. Post-processing of Midas Gen is very versatile. Midas Gen provides all the analysis and design results in contours, which enable us to evaluate the results more intuitively. This shows the beam moment diagram, and if we need to check the detailed result for any point of the beam, we can use the beam detail analysis results. And this shows the displacement contour and form myself stress contour. And vibration mode shapes. And also this shows the when we need to check the solid stress inside, we can use the isosurface and also various type of the results. Solid stress cutting plane. And this is the table output. We provide all the results in the table format as well. And this table can be exported to Microsoft Excel, as we can see in this picture. Since Midas Gen has been designed for the building structure, so we provide the very useful story-related results like story draft, story displacement, story model shape, irregularity check, so on. Especially when we work on the multi-tower, as we can see in this table, in this picture, we need to check those story-related results separately for this tower and the other tower. For this, Midas provides the useful feature which is called the define module. So by defining module, we can check the results for different modules separately. So we don't need to bring the data to Microsoft Excel or some other way. So it will also reduce our time. And the other useful feature is dynamic reports generation. We can enter all the input data and results in Microsoft Excel, Word file, and then if there is any change in the model input data, then this report can be automatically updated. I can show you with the program briefly. For this, I will use another model. So using this model file, I will try to create the dynamic report. For this, firstly, we can open new Word file or we can open our previous format. So I will open the previous format that I previously made. So if you have your own format report file, you can simply open it and we can enter the data to that Word file. So first of all, if I want to enter this 3D model file, by simply clicking this dynamic report image icon, 3D model. Okay. Once we enter the data also, if we go to the report tree, we can see the data we just entered and some other data like if we want to enter the function of the response spectrum, we can also enter it, response spectrum function. Or any other table or results. For example, the reaction table. By right-clicking and dynamic report table, we can enter the reaction table. Okay. Similarly, if we go to the report tree, we can see this table has been entered and also response spectrum function we just entered can be shown here. And some other results in the model view like dynamic beam diagram. So this data, beam diagram. Okay. After that, we can simply drag and drop. So from the report tree, we can just enter simply to this data and also response reaction table or response spectrum functions and beam diagram picture. So everything can be simply entered from using this drag and drop. For the frequently used data like section data, it is just by default, the data is already entered in the report tree. So simply drag and drop this data. The data can be shown here. And also some other text data like control data can be shown here as well. After that, if we have the changes in the model, if we have change in the model as I mentioned, for example, for the easy recognition, I will try to delete this part. So delete it and then re-perform the analysis. Then go to the report again, and by clicking this regeneration button, program will ask you which data you want to update. So I will enter all of them. Regenerate. So if there is any changes in the model during our design, it may take a long time to update the predefined report. But as you can see, the report can be automatically updated. So it will reduce our time a lot and also increase our productivity. So this report can be saved in Microsoft Word file. So the usage is very simple and easy. All the format can be changed just the same as the Microsoft Word, like this. Then this can be saved with this word. Okay, go back to the presentation and let's see the design capability. Automatic design and checking for RC, steel, SLC, footing, and slab design is available as per those implemented design code. And also we are continuously updating the implemented design code as well. Currently we had many updates in the Eurocode. So most of the latest Eurocode has been implemented in the program. For the database, for material, section, load, and pushover hinge, and also designs. Once we perform the design, we can check the results in these tables and also graphical report and detailed report. In this detailed report, we can check the all the equation and use the factors. And optimal design feature is also available. So for the steel structure, program can find the optimized section size with the various type of the results. Since this optimal design will be performed in terms of the strength, we can check the substability checking using our displacement optimal design. And for the high seismic zone, we can perform the seismic design such as capacity design and also strong column whipping design as per the ACI. So both European standard and ACI is implemented. And this is the meshed slab and wall design. So for the meshed slab and wall design, Udama formula has been implemented, and we can consider the skewed reinforcement for the irregular shape of the slabs. We can check the fracture design and substability checking, punch and shear check, and wall designs. Before we go to the project application, I will show you the programs with the general features from the creation of the models. I will use the pre-generated model file, the basic model file. So as we just see during the previous demonstration, this is the worktree which we can check all the entered data. So material, section, thickness, or boundary condition, everything will be shown in this worktree. And as I mentioned, simply drag and drop. We can change the properties, anything, boundary conditions. So for this model, I will firstly generate the meshes For this, I specify the material and thickness, and then clicking apply. The meshes will be automatically generated here. For the walls, same. Those walls also specify the material and thickness, and then mesh will be generated. Then, as we can see in this connectivity, the connectivity between the slabs and walls can be automatically considered, regardless the mesh size. It can be controlled using those options. So after that, and then I will enter the loads. For this plate element, we can enter the pressure load. For the live load, we can enter apply, and also superimpose the dead load. Apply. So load has been entered, then I will create the buildings using this basic model. We can use the useful feature for the buildings, building generation. So for the typical shape of the building, we can use this function. So I will make the 5-story building with the 3-meter height. So the building has been simply generated. Okay. Then we can enter the story data. As I mentioned, program can automatically recognize this story data. So click OK. If we want, we can consider the floor diaphragm, but since we modeled with the plate element for slabs, we will select the do not consider for the floor diaphragm. Then we can enter the lateral load like static wind and seismic load. For this, we can select the database. Among those, we will use the Eurocode database for the X direction. The amount of the load can be checked in this table and graphs. For the story force, story shear overturning moment can be checked. Apply. And for the Y direction, same. For the seismic load, we can enter static seismic load or response spectrum load. I will show you the response spectrum. For this, we can use the database for the design spectrum. Among those data, I will select the Eurocode. We can also enter our own function as a user type. So using this table, we can simply copy from Excel file. After that, enter the response spectrum load case. We can consider the auto search function of the major axis. So major axis of the building can be automatically searched, and response spectrum data will be entered to the corresponding direction. And also, we can select the modal combination type among those. If we want to restore the sign, as you know, during the modal combination, the sign will be ignored. But in the special case, like when we design the flat matte foundation, we need to restore the sign. In that case, we can use this option. And also specify the eigenvalue analysis data. We can also consider the accidental eccentricity. Okay. Then similarly for the y direction, we can enter the data. So all the required data has been entered now. Then in order to reduce the time, I will open the model file that I performed the analysis previously. So the model is exactly the same one that we just created. Using this model file, we will check the results. So with this model, firstly, we can check the deformation. For the specified load case or combination. We can see with the deformed shape as well. And the forces. Let's see the beam diagram. And also we can check the reactions. The largest value will be shown with these red arrows. And as I mentioned, all the results can be checked in the table format for the member force, displacement, anything. And I will briefly show you the design functions. For the beam members, we can specify the design code here. Following design code has been implemented, and we will use the Eurocode. Then so design results will be shown in these summary tables, and also it can be checked with the graphical report for the bending moment capacity and also shear capacity. So results of the lever input will be shown here. And also these results can be checked in the detailed text tables, text file with the all the parameter and information which was used for design. And also neutral axis location, everything can be checked. For the slab and wall design, for the plate element, we can check the required lip area. And also this data also can be checked with the detailed text file. So the wood armor moment and resistance of the slab can be checked, and the resistance ratio, wood armor moment, everything can be checked. Also, we can see the wood armor moment with the tabular format as well. So based on the member force from the analysis result, wood armor moment for the top and bottom about two different directions can be checked. Punching shear check. So critical parameter will be displayed here, and we can check the results with the ratio. So if the ratio is not satisfied, ratio is the shows the ratio between the concrete resistance and member force, the punching shear force. So in this case, if the ratio exceeds the 1, which means the shear rebar is required. In this case, the required rebar area will be also shown in this report. And also, substability checking is available for the stress checking, crack, and deflection. Especially for the deflection, we provide the uncracked and cracked deflections. Okay, so let's go back to the presentation. And I will briefly show you the project applications. As I mentioned previously, Midas chain has been distributed worldwide, more than 60 countries, and almost 6,000 copies has been distributed. And as you can see, the chain has been applied for various projects. Firstly, Beijing National Stadium and Beijing National Aquatic Center and Basketball Gymnasium and Beijing University and Seoul World Cup Stadium, Jeonju World Cup Stadium, and Incheon International Airport, and Beijing International Airport, Grand National Theater, and Pulse Dubai in UAE, Moscow City Palace Tower, and Guangzhou Twin Tower, Gate of Orient in China, and some other pavilions which has been applied for the 2010 Shanghai Expo. As you can see, Zen has been applied for the various projects, especially for those Shanghai Expo or 2008 Olympics and World Cup stadiums. This shows the partial list of the Midas site client. Okay, so that's all for our product introduction today. If you have any questions, please let us know via questions window so that we can answer for all your questions. Uh, Firstly, I would like to show you briefly for the isolators and dampers. Using this model, I will briefly show you. So this is the model file that we just checked with the slide. We assigned the isolators at the bottom of the column. So isolator has been entered here for its support. And Midas provides the isolator for the lead rubber bearing and also friction pendulum system isolator. So we assigned both the in order to check the results. Just for the test model, we assigned both. At each corner, we assigned the lead rubber bearing isolator, and also here we assigned the friction pendulum isolator. So as you can see, we can assign those, and then we can enter the nonlinear property for each component. After that, we can perform the time history analysis with this using the earthquake record. So by performing the analysis, as we checked, we can check the behavior of the structures. With this time function. And also we can check the results with the various type. For example, if we want to check the translations behavior of the y direction, in this point, this friction pendulum isolator, let's check it. With the shear force. So we can check this hysteretic curve. And also we can compare the behavior of the structure for these first nodes and first nodes. Those two with the time domain. So we can check the behavior of this red line represents the supports the first story nodes, and this blue line represents the loop floors nodes. So by assigning the isolator, we can see the difference is not that big. And as we just did, we can check this graph with the frequent domain as well. Okay. And also, do you have any other problem or any other question? Please let us know. For your information, we provide the isolator that you just checked, and also for the dampers, we can assign viscous dampers and hysteretic system dampers. So two dampers and two isolators are provided. Okay, if you have any other question, uh, for the viscous dampers, also it's similar. So we can assign the nonlinear property for the dampers, the damping coefficient, reference velocity, damping exponent, and bracing stiffness. We can select the damping type among three. So by entering those data for the dampers, we can also consider the damper. This is the viscoelastic and hysteretic system also. Based on this formula, the behavior will be determined. So those required field can be entered by the user. Okay. And one other question is about the nonlinear time history. Uh, since uh, since I do not have the model, corresponding model right now, so I cannot open the model, but we can perform the nonlinear direct integration time history analysis with the damping methods of those. And the time function can be specified just the same as this. So we can specify the end time and time increment. So by defining those, we can perform the inelastic time history analysis by entering nonlinear direct integrations. Uh, but if you are interested in inelastic time history analysis, uh, we can send you separately the corresponding materials via email with the sample model file. Since I do not have the prepared model file right now, I cannot show you, sorry. And if you have any other questions also, please let me know. Okay, thank you very much for your time and attentions. If you have any other questions later during using our evaluation version or during seeing any other material, please let us know. You can send the email to esupport@midasyuser.com or info@midasyuser.com so that we can contact you again. Uh, Thank you very much for your time. Uh, I will finish the session now. Thank you. Goodbye.